Hi everyone. I just wanted to make a quick video to add to my written portion of this discussion board. I read the article about GeoGebra and I just wanted you to kind of, for those of you who haven't seen it, to see what I was talking about or the article is talking about. GeoGebra is an open source resource, and the advantages of that is that basically anybody can use it. And also, it helps that it's an online platform so that students can use it from anywhere, and so they're not restricted to a handheld device like a graphing calculator. The drawbacks of it is that it takes a while for people to understand how to use it. But once that you get over that, then it has many uses for helping students visualize mathematical concepts. It's great for simulations, and even it has its place in some of the science classes such as physics, also for graphs and things like that. But like one of the things that they talked about in the article and they had images, was doing a slope of a line. Slope basically is the steepness of a line. So we're just going to keep it simple. I'm not trying to teach math here, but this is what they were talking about. Notice that as soon as I create everything that I do in GeoGebra, as soon as I do it, it creates a trail of what's happening. So I created point A first. It gave me the coordinates of point A. Then I did point B to create my line. So it gave me a coordinate of point B. But because now I have a line, it gave me the equation of the line. Now in algebra for students, we ask them to understand equation of a line. We understand for them to understand the slope of the line, which is that steepness. And we also teach students how to calculate the slope both from a formula, and also algebraically, but also graphically. And I think a few weeks back, Dr. Zantak actually had a video about those connections. But so GeoGebra can help with that also. So I just created a line and it gave me the equation of the line. One of the things that I can do in GeoGebra is actually use it to see different representations of an equation of the line. So this is right now in standard form, which is the default for GeoGebra. But I can ask it to give me the formula in the slope intercept form, which is makes it easier to see the slope, because we have taught students that in this format, this number right here before x, that letter m, is the slope. So according to the formula, or the equation, the slope is zero point 0.6. I can also ask GeoGebra to give me visually the slope by using the slope tool, and going to one of the points on my line. And notice that as soon as I do that, it gives me that letter M, which stands for slope in algebra. And you notice that even visually, it shows it as zero point 0.6, so the students can see that connection. So there are a lot of other things that can be done. In my post, I talked about using GeoGebra to understand trig functions. I'm not going to create all of that, but I want to show you the animation or simulation for the image that I included, and so that you can see how moving the point on the circle shows how the movement on the sine function. And then I can change that to cosine, so that they can see the cosine function. You can see the red now and see the differences between sine and cosine. I can add tangent, and so this when I was learning this, if this was around, I would have loved this. I had to do all of this in my head visually with pictures in textbooks. So it is a great tool. It can be overwhelming, but again, once students and teachers get a feel for it, it can be a very helpful tool. And as I mentioned also in my writing, especially in some of the special education classes, obviously we're not talking about trig, but you can use a polygon tool to create rectangles and and squares and things like that, and use it to do simpler things such as area and perimeter and things like that. So just wanted to share all of that with you. Hope I didn't cause too much anxiety.